chat as usual, and Risa, I think, is happy for these to be shared. So.
Okay, I've had a little bit of trouble with my computer freezing, so hopefully we make it through. But somebody will need to let me know if I'm like caught in action and just stop. So here we go. Welcome everyone, and thank you, Michael, for having me. I'm so honored to be here. So the title of my talk, I think I froze, is, oh wait, I don't know. Can you let me know if, let me see, sorry. Okay, I'm gonna keep going, but Michael, let me know if I need to do something. Okay, so.
All looks good from here.
Okay, good. So exploring theoretical frameworks, framework flavors to spice up analysis of students' atomic level sense making is the title of my talk. And I want to talk about the word sense making because every word that we use in education feels like a loaded term. Like it's mired in complexity. It can have several meanings. And we go to the research and we find a framework around it, and that is really like, that's great in some ways and it's hard in other ways. And so I'm here to kind of share my experience with these kinds of theoretical frameworks, and I in no way feel like an expert, which I suppose if you're spending time here listening to me and you're thinking, well, why are you speaking then? I ask myself the same thing many times. So here we go. Let's see. So I just wanted to clarify that sometimes what I want to say and how I express it are two different things. So I'm letting you know that. Michael, you can see the next slide. Okay, yes, thumbs up.
Yes, yeah.
Okay, good, because I see myself frozen in the screen, but good. All right, so so just giving that a couple of, I don't know, just a little heads up there. And to start off with, I'm just going to give you kind of an overview of a qualitative study that I did in 2018, examining how students, I used the word learn to start with, and I changed it to elicit ideas from contrasting redox reactions. And again, I think it's one of those things where whenever you're doing a study, you're constantly like tweaking and looking at it, like, what am I really asking? And so that process, I hope to put a lens on. So here's what the study outline looked like, just to give you a sense. This study actually is part 2 of a 2-session study. And the first study, we looked at precipitation. And then the second session, we invited students back. And of the 20 that we started with, 15 persisted. And during that time, we looked at redox and acid base. So I'm only going to share you a little part of that, which is redox. And it's actually a substantial chunk. And so the way that it would start is that I would share a video. So I'm just going to quickly play my video here and I'll let you see it. It's got a little music that goes with it. So I'm gonna, well, so as that plays, the idea behind the video, and it's designed after kind of these, you know, Facebook cooking videos, is to not like be in a ton of detail, but to give a perspective from, if the students had lab experience, then they're going to connect to this rather quickly. And we wanted to hit on not just like wowing them with like a demo, but to kind of frame it as more of an experiment where there are controls, and that instructors, should they want to, they could kind of use this as in their lectures. So everything that we design has usability for taking into the lecture environment and using it in an active learning type of setting. So that's where this is headed. I'm going to kind of scroll because I know we don't have a ton of time and I want you to actually do some stuff. So I'm going to move forward a little bit. As you can see right here, it's kind of fast forwarding through to show you the reaction, and the reaction doesn't occur in the outer beakers. It's only occurring in the central one. And you just see some stuff. A lot of times when students are watching this, they're kind of like, wow, that's, you know, they think it's cool. And then they're reminded, some of them are reminded of things they've done in the past. The connectivity is tested after, and then at the end, we give kind of a close-up perspective of what it looks like if you could really, you know, zoom in. So the research questions that I'm focusing on at this time to kind of frame this study is, how do students describe, explain the atomic level of the redox reaction between solid copper and aqueous silver nitrate before and after viewing the contrasting animations that are going to come next in this hierarchy of steps in my methodology. And then what ideas do the contrasting animations elicit is really, again, just to remind you of how I'm thinking. Those aren't the questions that I ask the students, although I do ask them to explain a lot. But these are questions that I think about as I'm, doing or to frame the study. And oops, here we go. So the next step is that we took pictures from our animations that the students you haven't seen yet, and I painstakingly cut these out, glued them, well, laminated them first, and then glued them to magnetic pieces of they're like strips, and cut these out. It was great arts and craft project. And the idea of this was that I wanted students to be able to play with the atomic species that they would see modeled in the animations. And so up in the right, you see that they're presented with a key, and this allowed them to again, just kind of start to already think about these things before they would see the animations. And this gave me a sense of what they thought about. And then after this, they are shown 3 animations. Now, I'm not going to go through and show you each animation. I guess I could start and play them while I just yammer away. These are the animations. And what I tell the students is that I'm going to show them, I show each one consecutively. And when before I even show them, I tell them, here are 3 representations that have been designed. Now, they may or may not be scientifically accurate. And your job is to think about what would make one more scientifically accurate than another. Is there one that is more scientifically accurate? How do you decide that? So they're kind of presented with that kind of preamble going in to view the animations, and specifically, hey, none of these could be correct. And what I'm trying to do there is kind of plant this idea that, models are always simplifications. And so what do we look for? What are the pieces that really, make sense to us, and what are things that don't? How do you make decisions about that? So after they view those animations, and again, they talk about it, they rate them actually. They're given a worksheet where they tell me how accurate each of the parts are. And so they're asked, okay, how accurate do you feel the aqueous silver nitrate solution was presented in this reaction? How accurate do you think solid copper is, and the mechanism and the products? And then they talk a bit about how compared to their model, where again, I need to go back and just say that when I show them the experimental evidence, what I'm trying to do when I ask them about that video is to ask them, hey, what do you think about? And usually students all the ones in this study did not naturally go to the atomic level to explain the reaction. And so when I showed them the model pieces and they had to actually play with it, I was pushing on that. I'm like, hey, I'm forcing them to describe to me what they think that atomic level could look like, which is something that many of them express they've not done before. And they'll say, I'm really uncomfortable with this. I don't know. No one's taught me this before. That kind of comes out. And then but then they play with it and they get an idea. All right. So then they go to the animations and they see these animations. And again, what do these tell you? And then the last step is, would they like to revise the initial model that they made? So they go back to those models that they started with that are still out in front of them. And I ask them, would you change anything? Did you get any ideas? And what would you change? So that is kind of the crux of the research design. And one of the things as I was preparing for the talk that I started to look for was how to kind of characterize this study to assist you as you come in to help me. So I want to just kind of talk about the empirical setup. And this is asking the question, what instances of thinking and learning are studied? And basically what we wanted to uncover was what the students thought about when they constructed their models, what ideas were elicited from viewing the animation. So that's kind of part of what the instances of thinking and learning that were studied were. And then we wanted to capture aspects of the learning. So capture what aspects of the learning phenomena were captured and how. So the way that we captured the learning was through the video and audio recording of the study session. Worksheets were involved where they were rating their animation accuracy and their confidence. they constructed and revised their models. And then the question is, what do students focus their attention on, and what is salient to them during that modeling process? So the next step is the reduction step. So what do we attend to, and what is captured? And so we care about how students make sense of the atomic level through the modeling. We're interested in the ideas the animations elicit during the exercise and ways that students reformulate their way of thinking. And segments from the video relevant to this analysis were extracted. So that reduction step is really key here, because I have to keep going back to this over and over and over again, because I need to be thinking about what am I going to search for in terms of theoretical frameworks. So let me just state at this stage, well, let me hit one more stage and then I'll go back and talk about that theoretical framework. So the next step then is pattern finding. So how do we find patterns in the reduced data? And my typical way of going through the data is that I use a lot of grounded theory and constant comparative analysis, and then I go back and I kind of study the frameworks. So so that's kind of my process. I'm always trying to make sense. I need to get really, like, I've done the interviews. I've gone through 2 hours roughly with, you know, this particular session, 1 hour for the redocs. And I'm really close to my data once I've kind of gone through each of the transcriptions, you know, because I've transcribed them. I try not to put the transcription off to my students. I actually try to transcribe things myself. Because it, again, connects me to the data. It's part of the process that I use. And then I'm like basically like parsing through it, like moving chunks here and there, coming up with ways to kind of organize the data. And it's a long, painful process. So the theory. So here's where we start to get at, like, the whole purpose of this talk is to kind of go into how do I use these theoretical frameworks? How do I use them? So theory, I connected with this definition. To understand theory is to feel some wonder that one never saw before, what now seems to have been obvious all along. I feel like that happens in my research every time. Like every time I'm like, wow, this was really obvious. Maybe I should have seen this from the get-go. And so it's in part when you're so close to things or when you've done the interview that kind of happens. And this is why I think the length of time that it takes to do these, you're getting close to things. You're looking at what the literature says. You're constantly kind of going up close and then and going back. So kind of like putting it under a microscope and then taking a step back and going, what does this really mean? At this point is really when I ask myself, what is the point of the research that I did? Why did I do this? and so it's again, kind of this painful process. And sometimes I actually find it really hard to articulate what the point of my research is. And I know that this is kind of, again, something that I think in our training from the time that you're a graduate student, I can remember my advisor asking me, Resa, what's your research question? And it's more than just being able to drone off your research question. It's so much more than that, because but in a way it goes back to that being able to succinctly communicate what that research is about. But that's really also, it's not just important in, like, when you're having a conversation with somebody about what your research is about. It's really important in the research process, because the more connected you are to what you're trying to investigate, I think the better it makes you when you go into looking for what's in the literature. So that's where I'm kind of headed next. So what do I do? So this idea of identifying a theoretical framework, we're trying to isolate what matters in describing the study so as to produce an optimal description, one in which the complex behavior of the study arises from combinations and elaborations of the constructs and their interactions. And this is from Joe Reddish, and he's actually going to be, his paper is going to be the one that I ask you to kind of review in this session. So when the first question is, how do you find the framework that fits? I ask myself this every time. And it's really constructed from the theories and experiences the researcher brings to and draws on in conceptualizing the study. So again, going back to that, how do you get succinct about what it is that you're doing? And so what I tend to do is once I've kind of got that, like, okay, this is what my research is about. One of the things that I actually did was I looked at structure and function, because I thought that I was seeing in my students when they were modeling, I thought I was seeing a lot of them playing with the structure and the function of how those pieces kind of interacted. And so I ended up going to a paper by Vicente Tallinger, which looks at progressions and reasoning about structure-property relationships, and I felt like it really didn't fit. And so then I was like, all right, but I found something in his paper, and that was actually the Reddish citation. And so I went to the Reddish paper, and the Reddish paper was like, like I had kind of an epiphany moment where I was like, this is what I want to look at. And so that was kind of how I meandered and found the framework that you're going to look at today. But I'm still trying to decide, like, does this framework fit? And that's where I'm going to ask you to kind of assist me in exploring that. And maybe you'll think that it does, or maybe you'll think that it doesn't, but that's the game we're going to play. So what is this theory? What is this framework? The theoretical framework is by Joe Reddish, is actually titled in this paper, A Theoretical Framework for Physics Education Research, Modeling Student Thinking, but it's really a cognitive model. And so you're gonna ask, why physics? Well, I mean, most of the information connects to chemistry as well. And so I felt like it was it has potential, let's put it that way. So what you'll notice is that his cognitive model framework kind of splits into two areas, the neurosciences and the cognitive science part. And he's looking at the interplay between these two. And he talks about the framework consisting of intermediate level cognitive structures. So he goes to neuroscience to take this really close look at how we learn, how neurons fire, how that changes as we continue to learn. And then he says, that's not altogether super useful to us. So let's focus on the level of individual thinking. And so that's when the cognitive science comes into play. And so I want to point out this resources term. Resources are intermediate level cognitive structures. And so, and that's important because resources is a term, it's a term that we all probably commonly think about and use. You talk about resources that are readily available to you. But this is kind of a new spin on that. It's looking at what are these intermediate level cognitive structures. And so I'm going to keep kind of going back and forth between these terms, because I feel like it's not always like if I just use the word resources, I think it gets a little lost. So the two sets of structures that he looks at are associations and controls. And so which resources go together, and with the controls, the environment and cues that activate the particular associated patterns. So associations, which intermediate level cognitive structures go together, and again, environment and cues that activate the particular associated patterns. So through the structures, Reddish identifies models appropriate for analyzing student thinking and learning. And so this is where you guys are gonna come to get to play a little bit. So the framework, if you wanna, you can use a QR code to access a worksheet that I've created that basically outlines what I have here. And it's a long framework. It encompasses all of these 1 through 4 items. And so I'm going to quick copy, oops, I can't do that. I have to escape for a minute, sorry. So I'm gonna copy and paste this link. Oops, let me go back, sorry here. I'm gonna put this in the chat so you can access it. And let's see here. Oh,
I can get the chat, Resa, if you want to continue explaining. I'll put the link in the chat.
Awesome, thanks, Michael. All right, so the idea here is, again, he breaks it up into the neurosciences, cognitive mechanisms, knowledge and knowledge structures, epistemology, and expectations. And this is where the resources comes into play. So what I'm going to have you do is I'm going to actually assign you to groups. And in those groups, I'm going to ask you to tackle a section of this paper. and use that portion of the framework as the lens that you're going to use to look at some of my videos of the research session with a few students. And you're going to get some freedom of choice with that. So there's going to be a portion of time where I just give you to read and kind of skim through, and then a portion of time where you get to actually do some working together. So the purpose of the task that you're going to embark on is that you're going to examine how this framework provides an explanation for how and why students' preliminary ideas of a simple redox reaction impact their review of contrasting animations. You might need to revisit that, and it's going to be on the worksheet, so don't worry about having to go back to this slide. And so the question is, what ideas do the animations elicit? How is that information used to make model revisions? So in your breakout groups, you'll be assigned a framework, and I'm gonna do it as follows. So I'm gonna, again, exit, and I'm gonna show you, let's see here. Let's see, framework. Okay, so you should all, yay, I see you entering in. So if you see this slide, oops, I'm gonna see if I can make that a bit bigger. All right, so when you go here, it says the theoretical framework task. You're going to read the theories that are part of the framework, and you can click on the link right there, and that's going to take you to that outline. And let me actually go there. So if you go to this worksheet, I'm just going to quickly tell you that when it comes to this, come on. It's a little slow, probably because everybody's trying to access it, right? Here we go, good. So in our groups, one group is gonna focus on, the group one will focus on this portion of the reading. Group two will focus on this section of the reading, and so on. And so it'll go group 1 through 10, but then group 11 will be back doing the same reading as group 1, 12 for group 2, and so on. And then group 20 would do this reading. So when you get in your group, the first thing you're going to do is you're going to read and skim the framework for constructs. And then you're going to go back to this table, and you're just going to outline the constructs in your group, kind of chat them out, outline them, and then you're going to go, I'm sure you get that to go away. Well, you should be able to see it, but then, there we go. So then you can go to the, after you've outlined your framework, then you can go to either one of these, K1, K2, or K16. There's videos and transcripts there. You're gonna record the video segment, evaluate it, and ask how does it fit, and then how do the constructs help. All right, so that's the task. I'm gonna let you go. I'm gonna time it. I'm gonna check in with you in about 10 minutes just to see how you do with the reading. So I'm going to kind of turn you loose. So Michael, I might need your help with creating the breakout group.
Yeah, so just to say, we have 15 minutes in total, so we can then issue instructions to the breakout room if people need clarity. So what's the time frame in terms of, so people maybe 5 minutes on reading?
Yeah, let's take 5 minutes on reading, and then start to look at the K16 might be, well, pick your video choice and try to, just pick one of them and connect to it and see how it goes.
Okay, so so people in breakout room 1, 11, and so on, choose number 1, and we'll pick it up from there. So I'm going to now assign to breakout rooms, so up people go.
Right, and you can add on the to the groups.
No, I'm not going to assign to breakout rooms. Hang on, let me. What's going on?
So the only tricky thing is that usually it would be good if I could go into the breakout group, but that's okay.
So you should be able to dance in and out of rooms if you wish.
Okay, great.
Yeah.
I don't see that I can though. I see that, hold on.
Let me move you into room 1 so you can get started there.
Okay. Oh, there we go.
So I think that should be everybody assigned to a room. And now they just need to click join. So in breakout rooms, if they click join, if they haven't joined a room yet,
Did I miss
just message me in the chat if people have queries.
I wonder if I missed my my room.
So Suzette, where am I? Had you a particular room?
I must have missed the the notification.
let
Looking
me
down.
just check how I can get you into a room. Okay. Move you to.
Is there something I should?
So I'm not sure how it looks from a user point of view to join a room, but there should be a. Do you see breakout rooms at the bottom of the screen to join?
I don't. Let me see. I don't see anything. Like, where did I? It came up last time, so I wonder if I just missed it. Uh-oh.
Just trying to see what room you were in, so that. Sorry about this one. Is anybody else? Is anybody else looking? Sorry, Suzette, did you?
Yes, it's still saying I need to be assigned. I guess I went out and came back in somehow. I guess I lost my connection. But it said the host has opened breakout rooms. Please wait to be assigned. So.
Yeah, I just don't see an option.
That is weird because it worked the first time.
Yeah. Sorry about this. Oh, here we go. Here we go. Assigned. Do you have a particular room number in mind?
No, just go for it.
All right. Room number 9.
All right.
I think for those that are still out there and not in a room, if you are able to just dive in, kind of pick any particular section that you want to, you might take the resources section, or you might just kind of skim it and then look at the videos. That might be the best route to go. Unless you're driving, then you shouldn't.
So we have about 9 minutes left, Resa, just to add a slight little bit of pressure onto you.
Obviously, I never budget well. So, Michael, I'm gonna actually, I don't know how much they're gonna be able to do. So maybe what I'll do is, I think we can probably leave this open where at a later time, if they want to, they could go back to it if they're so enthusiastic to give that a whirl. And
sure.
then,
Well, I mean, I guess we'll have the lunch hour if people want to play away.
Yeah, and they can look at a video and kind of connect to a framework, so that they can be something that they do, and they can always connect to the Google Doc, and then it'll be a record. I think I'll offer that as an option, and that way, So let's see.
So do you want to give it maybe 3 more minutes, and then, well, you've got 8 minutes left, so however you want to.
Yeah, can you tell me when 3 minutes? Well, I'll at 6:05 I'll just go back on. And
great. So it just takes a minute to get everybody back in. So I'll close the rooms at 6:05, and then that'll give us a minute.
Yeah, that'll work. Hopefully that's okay. I think. You know what? Let's go ahead and
close.
Oh, I am froze. Oops. Wait a minute. let's go ahead and let's bring him back now because it looks like
Okay.
not many of them are in the work
Okay.
sheet.
Yep.
And then I'll just go. Yeah.
So just 60 seconds and then.
Okay. Great.
Resa, it's so good to see you.
Hey, Vanessa. Good to see you too. Are you driving? You're actually driving. Oops. You're muted.
So sorry, I think that.
No, that's okay.
Oh, sorry. Yes, my daughter woke up and I needed to get her to school so I can enjoy the rest of the conference. And now I'm heading back home. So I'm sorry I had to do this during your talk. I really wanted to sit down and enjoy it.
No worries.
So 15 seconds and we can resume.
All right. Thanks.
And that should be it now.
Okay. So I need to go back and share my screen. All right. Hi, everyone. Sorry. Obviously, I know you didn't have enough time and you're probably like, what, Resa? And just know, remember that first slide that I showed you where I told you I'd be all over the place? That's just a little insight to the kind of person I am. So here we go. I'm just going to kind of, here's what I want to tell you. One is that when you get a chance, it would be, and if you're feeling like, hey, this is fun, I'd like to play with this. What I did personally is like when I'm looking at the videos, I try to connect or look at the transcript. I try to connect with the with what I read in the framework that Reddish wrote, and I start like I get ideas, and so for me, I'm like writing all over it, going, oh, here's an idea. This is where this connects, and that's really kind of my route toward finding the fit of the framework, and so when it comes to this reflective piece, as you apply the framework, it's important to consider what aspects fit well with the video and the transcript. That's kind of the question that I'm always kind of tapping into. And what aspects are challenging to fit, what are limitations and what are weaknesses. And when you're writing, that's what goes back into, like, at least what I'm working on right now with a current paper is I'm trying to go back and consider, all right, what are the limitations and weaknesses, how do I address those, but yet still convey why the framework feels like the fit that I, and why I picked it. And then as I go through my data, I'm trying to connect to those framework constructs and showing how that comes out in the coding process and how it makes sense in the discussion. I'm trying to build on that. And, I got to tell you, like I just recently, I'm going through revisions with the paper, and maybe my reviewers are out there, but this is what I'm actually trying to do. I'm actually trying to really think through this. And it's an ongoing process, right? And you kind of have these moments where you feel like, wow, maybe I don't really know what I'm doing. And that's where I think we as like a community, I think it's really important for us to kind of share out how we're doing with these things, and to let people know this is kind of a normal process of the interview, or not the interview, of the research process. So I'm going to add a concluding frame, which is having a theoretical framework and some theories of how students think about the atomic level as conveyed in the contrasting animation activities, partnered with the situational way the animations are presented, can help instructors and visualization designers construct instructional environments in which the tools are used more effectively. That's kind of the hope, right? Is that's what comes about from doing it. And, again, it's kind of that ongoing process. So just to do a few acknowledgements, of course, Michael and Ashling, thanks for inviting me and organizing this. And my collaborators, Saville, Sarah, and Adrian, and my undergraduate researchers, Jonathan and Truk, have been helping me with this. And of course, this NSF has given me the chance to do this work. Thought I'd share a little bit of coffee with you. I didn't drink any while I was on, but I should have now. These are just the collaborators to put a picture to the people. And these are my undergraduate researchers. This is Truk, and this is Jonathan. Truk's holding one of the magnetic boards that I use in my research. And that, my friends, is it. So what I want to do is I'm going to escape this room and I'm going to take a look I just want to go back to this worksheet and encourage you, if you're feeling inspired and you revisit the framework and you want to take a look at the videos and have a go of it, the Google Doc is open for you to explore and play with that. But of course, I mean, you know, I don't know if you want to do that as homework. We're at summertime. Anyway, I'll leave it open. I'm going to unshare and I'm going to take some chats. So
Thank you very much, Resa. That was fantastic. And I mean, I think just conveying a sense of the importance of thinking about theoretical frameworks is really valuable. And hopefully people get an idea of playing away with your videos, thinking about associated frameworks, really starts to spark some ideas of how important that is in terms of how we view our analysis. So thank you very much for sharing a very difficult topic with us. I'm just going to